Hello, dear space explorers. This is the QUASARIA channel, and today we're beginning an incredible journey through the most amazing structures in the universe, galaxies. Imagine trillions of stars united into enormous cosmic islands, floating in the infinite ocean of space. Each galaxy is an entire world with its own history, its own mysteries, and its own destiny. And today we'll start with the closest and most familiar spiral galaxies. We live in one of them. These galaxies create the most stunning cosmic landscapes, and they will be the heroes of our first episode. This will be a 5-part series where we'll explore all the main types of galaxies in the universe. Fasten your seatbelts. We're embarking on a journey billions of light years long. But before diving into details, let's cover the basics. What is a galaxy anyway? A galaxy is a gravitationally bound system of stars, star clusters, interstellar gas and dust, dark matter, and dark energy. Sounds complicated? Let's simplify. Imagine a giant cosmic city. Stars are its inhabitants. Gas and dust are the building materials for new homes, that is, new stars. And dark matter is the invisible foundation that holds this entire city together. Galaxies differ in size, mass, shape, and age. The smallest dwarf galaxies contain just a few million stars, while giant elliptical galaxies can contain over 100 trillion stars. But spiral galaxies are considered the most beautiful and dynamic. They make up about 60 to 70% of all galaxies in the observable universe. And most importantly for us, we live in exactly this type of galaxy. Our home galaxy is called the Milky Way. This name comes from ancient Greek mythology, where the Milky Band in the sky was believed to be spilled milk from the goddess Hera. The Milky Way is a classic barred spiral galaxy. What does that mean? Let me explain. The diameter of our galaxy is about 100 to 120,000 light years. To understand the scale, light, which travels at 300,000 kilometers per second, takes 100,000 years to fly from one edge of the galaxy to the other. The Milky Way contains between 200 and 400 billion stars. We don't know the exact number. Too much dust and gas interferes with counting. Our sun is just one of these hundreds of billions of stars. We're located approximately 26,000 light years from the galactic center in one of the spiral arms called the Orion Arm or Local Arm. The sun makes a complete orbit around the galactic center in roughly 225 to 250 million years. This is called a galactic year. Imagine, since the time when dinosaurs first appeared on Earth, the sun hasn't even completed one full orbit around the center of the Milky Way. At the center of our galaxy is a supermassive black hole called Sagittarius A, pronounced Sagittarius A star. Its mass is about 4 million solar masses. This black hole creates the gravitational pull that holds the entire galaxy together. Now let's examine in detail what parts make up a typical spiral galaxy. The nucleus, bulge, is the central, convex part of the galaxy. Here the concentration of stars is at its maximum. The nucleus contains mainly old, red stars. They formed billions of years ago when the galaxy was young. The temperature and density in the nucleus are so high that new stars practically don't form. The disk is the flat region where the spiral arms are located. The thickness of the disk is relatively small, only about 1,000 light years, while the diameter can reach 100,000 light years or more. Most star formation occurs in the disk. The spiral arms are the most beautiful and intriguing part of the galaxy. They look like twisted waves emanating from the center. Young, hot, blue stars concentrate in the arms, as well as regions of active star formation, stellar nurseries where new luminaries are born from gas and dust. Interesting fact, spiral arms are not fixed structures. Stars don't move together with the arms like will spokes. Instead, the arms are density waves that move through the galactic disk. Stars fly into these waves, slow down, creating regions of increased density, and then fly out the other side. The bar. Many spiral galaxies, including the Milky Way, have a bar, an elongated structure of stars passing through the center. The bar plays an important role in the galaxy's evolution, directing gas toward the center and stimulating star formation. The halo is a spherical region surrounding the disk. The halo contains globular star clusters and individual old stars. Most of the galaxy's dark matter is also concentrated here. The halo can extend much farther than the visible disk, up to 300,000 light years or more. One of the most common questions: why do spiral galaxies have this shape? Why are they twisted? The answer lies in the physics of rotation and gravity. When a galaxy forms from a gas cloud, this cloud already has slight rotational motion. As the cloud compresses under its own gravity, the rotation speed increases, just like a figure skater spins faster when pulling their arms to their body. But different parts of the galaxy rotate at different speeds. Regions closer to the center complete an orbit faster than outer regions. This is called differential rotation. Imagine coffee with milk that you're stirring with a spoon. The liquid near the center of the cup moves faster than at the edges. If you drew a straight line from center to edge, it would twist into a spiral over time. The same thing happens with galaxies. Initially random inhomogeneities in matter distribution, amplified by gravity and differential rotation, form density waves that we see as spiral arms. But there's another factor: interaction with other galaxies. Even gravitational attraction from a neighboring galaxy passing hundreds of thousands of light years away can create or enhance spiral structure. Computer simulations show that spiral arms are not permanent structures. They can form, break apart, and form again over billions of years. They're dynamic, living structures. Not all spiral galaxies are the same. Astronomers classify them by several parameters. There's the classical Hubble classification, named after the famous astronomer Edwin Hubble. He divided spiral galaxies into several types. Type SA, galaxies with a large nucleus and tightly wound spiral arms. The arms practically adjoin the nucleus. Such galaxies have many old stars and little active star formation. Type SB, intermediate type, medium-sized nucleus, moderately wound arms. The Milky Way belongs approximately to this type, more precisely to the SBB subtype with a bar. Type SC, galaxies with a small nucleus and widely spread arms. Many young stars, active star formation, bright blue regions. If a galaxy has a bar, the letter B is added to the designation. For example, SBA, SBB, SBC. There are also intermediate types and more complex classifications, but the main idea is simple. The more tightly wound the arms and the larger the nucleus, the older and calmer the galaxy. Interesting fact: About 2/3 of all spiral galaxies have bars. Bars aren't permanent. They can form and disappear during a galaxy's lifetime. It's believed that the Milky Way acquired its bar relatively recently, just a few billion years ago. One of the main features of spiral galaxies is active star formation. In the spiral arms are enormous clouds of molecular hydrogen, the primary material for creating stars. These clouds can have masses of millions of solar masses and sizes of hundreds of light years. When a density wave passes through these clouds, the gas compresses. If the compression is strong enough, the cloud begins to collapse under its own gravity. Denser nodes form inside the cloud, which over time turn into protostars and then into full-fledged stars. The most massive and hot stars live only a few million years, then explode as supernovae. These explosions produce heavy elements, carbon, oxygen, iron, and others, which then become part of new generations of stars and planets. That's why spiral galaxies look so bright and colorful. Young blue stars in the spiral arms create contrast with the yellow and red light of old stars in the nucleus. The star formation rate in the Milky Way is approximately 1 to 2 solar masses per year. This means that every year the equivalent of 1 to 2 sun-sized stars is born in our galaxy. It may seem like little, but over 1 billion years, that's 1 billion new stars. Let's look at some of the most famous spiral galaxies that astronomers have studied for decades. The Andromeda Galaxy M31, our nearest large neighbor, located 2.5 million light-years from us. It's the most distant object visible to the naked eye. Andromeda is slightly larger than the Milky Way and contains about 1 trillion stars. The Whirlpool Galaxy M51, one of the most beautiful spiral galaxies, located 23 million light-years away in the constellation Canes Venatici, famous for interacting with a smaller companion galaxy, creating a stunning visual picture. The Sombrero Galaxy M104, a spiral galaxy we see almost edge on. A dark dust lane creates the effect of sombrero hat brim, located 28 million light-years away. The Triangulum Galaxy M33, the third largest galaxy in our local group after Andromeda and the Milky Way, located about 3 million light-years away. Each of these galaxies is an entire world with its own stars, planets, and possibly civilizations. And they're all our neighbors in the cosmic abyss. So, friends, today we explored spiral galaxies, dynamic, beautiful cosmic structures that are home to billions of stars and possibly countless forms of life. We learned that our Milky Way is a typical barred spiral galaxy, that spiral arms are density waves rather than fixed structures, and that new stars are born in these arms. Spiral galaxies are galaxies of life, galaxies full of energy and motion, but they make up only part of cosmic diversity. In the next episode, I'll show you the complete opposite: elliptical galaxies. These ancient giants are called zombie galaxies. Almost no new stars are born in them. They consist of old, dying luminaries. How do they form? Why don't they have gas to create new stars? And what will happen when our Milky Way collides with the Andromeda Galaxy and turns into one of these zombie galaxies? Don't miss the next episode. Like, subscribe to the QUASARIA channel, and turn on notifications so you don't miss the continuation of our journey through galaxy types. See you among the stars.